Hi everyone, thank you for joining in. Myself Paranjay Sharma, I am a student at IIPS DAVV Indore. This video is regarding my assignment for operating system. So let's begin. So the topic I have selected is CPU scheduling. So let's start. First, talking about something we all use every single second or every single day, but probably never think about it. That's CPU scheduling. So, like, think about your phone or laptop right now. You have probably got Spotify playing, or 20 Chrome tabs open, or maybe a game running in the background. But here's the secret: your computer usually only has one brain, the CPU, during the actual heavy lifting at any given second. So, like, how does it look like? Like, everything is happening all at once. It's all about multi-processing, etc. It's all done through scheduling. So to make this super simple, we will take an analogy. Imagine a bank with only one employee, but the line of customers is about 50 people long. If the employee is slow or picks the person with the most complicated paperwork, first the whole line gets angry, like they have to wait. So CPU scheduling, you can take in it as like the rules that the employee use to decide whom to give priority more or who do I help next, so that nobody waits too long. Is the difference between smooth running system and one that freezes every time you try to do something simultaneously, like opening a PDF while playing a game, etc. So moving on, uh, like, how do we judge a CPU? So for that we have scheduling criteria. So now before we look at the rules, we need to know how we grade them. So how do we know if a scheduling strategy is actually good or not? So we use 5 metrics. So first one is CPU utilization. So it tells, like, is the CPU actually working or is it just sitting idle? Like, we want it to be busy 100% of the time, right, to utilize it optimally or maximize its utilization. So next is throughput. It basically means in simpler language, like how many tasks are we finishing every second. So the next point is turnaround time. This is basically the time starting from opening the app to finishing its loading, like the total time that uh, it took for opening the app and finishing the loading process. That's called turnaround time. Then comes waiting time. So this is a major weightage in scheduling criteria metrics. So how it what it basically means is how long is the process just sitting in the line doing nothing. Like, then comes response time. It basically means, from the name itself, how fast do we get the first feedback. So coming to the next part, uh, it's basically about three managers. uh, if we can if we take it as an analogy. So the next topic is types of schedulers. So who is actually doing the work? Like, it's not just one person, it's always a team of multiple people, but here in our case of CPU scheduling, it's a team of three schedulers. So the first one is the long term scheduler, as we can see over here. So think of it as the gatekeeper. It decides which programs even get to enter the system from the hard drive. The next one is medium term scheduler. So this, we can take it as an analogy of a bouncer, right? First one was gatekeeper, then comes bouncer. uh, in technical terms, we can say that if the system gets too crowded, it kicks some processes um, temporarily to the disk to save the space. This is called swapping. So swapping comes over here. We can call it as a swapper as well. And this one was, in technical synonym, we can say it as a job scheduler. Then comes the third team member, that is the short term scheduler. So it is kind of a dispatcher that picks the task, gets the CPU right now, and makes the decision in milliseconds. So it is incredibly fast. It gets the work done of the processes that get selected from these two schedulers. So moving on to the next slide. So now we have like simple rules or algorithms. This chart is called Gantt chart. So first we have is FCFS, or what we call is first come first serve. So this is like the line in a grocery store. For example, you are at a DMart or someplace similar. So if you are behind someone buying 500 items, so you are stuck waiting even if you just have one item to buy. It's simple, but it can be really inefficient sometimes. So then like we have something better, what we call as SJF, shortest job first. So in this we put the quickest task in the front of the line. Why? Because it drastically lowers the average waiting time. If everyone with a 1 minute task goes first, they are all happy and gone quickly, leaving the CPU free for the like the 500 item task that may last 30 minutes or something like that. So we have different algorithms as well. So moving on to the next slide, what we have is like the VIPs or the timers, we can say. Since SJF can be unfair, we have two other popular methods like I told you earlier. First one is priority scheduling. So in priority scheduling, we can take it as an analogy of a VIP line at a club. So certain tasks like system updates or mouse movements have higher priority than say a background print job. Like to stop the low priority jobs from starving to death, like if we do not uh, check on them, the processes might die. So that's called aging. So to prevent that, we use aging. The longer a task waits, the higher its priority becomes. Like it's pretty understandable. Then finally we have round robin algorithm. Like this is the most fair algorithm, we can say. It's used in most modern systems. So in this, every process gets a tiny slice of time, maybe say 10-20 milliseconds. If it's not done, it goes back to the next person or the next process, we can say. So nobody waits too long and everyone feels like they are making progress simultaneously. So basically these are used in our modern computers. So it feels we are doing multitasking, but round robin algorithm is what is happening behind the scenes. Moving on to the next topic, and this is the final topic of my presentation, which is multiprocessing and performance of the computer. So to wrap things up, we can say that we don't just have one CPU, but instead we have a multiprocessor system, right? Most of our laptops use what we call is symmetric multiprocessing, SMP. This means each core of our processor can make its own scheduling decision. Like for example, even your mobile phones are of 8 cores or similar. So each core can make its own scheduling decisions, right? It's like having 8 bank tellers instead of it's like having 8 different bank employees instead of one, each with their own line, right? If we take it as an analogy. So like, why does this topic even matter to us? Because it's about understanding the logic that makes our digital world feel fast and responsive. Like whether one is a developer or just a user, Like knowing how the system thinks and works about the task that we give it, it helps us understand why our computer behaves the way it does. So that's CPU scheduling from my side. uh, Thank you for watching. Have a nice day.